Dr. Henry, Alternative Foundation designed for temporary housing units. Dr. Henry, please.
Good day, everyone. My name is Georgian Henry. I am a final year civil engineering student at the University of the West Indies, Mona campus, Jamaica. It's my pleasure to be presenting on the study Alternative Foundation Designs for Temporary Housing Units. This study grew from Food for the Poor. Food for the Poor is an interdenominational Christian organization that assists the poor in 17 countries in the Caribbean and Latin America. Food for the Poor Jamaica is the largest charity organization in the island and is an affiliate of the larger organization based in USA. Food for the Poor Jamaica has built over 30,000 houses across the island over the past 30 years. They now desire to improve the current design while maintaining a suitable cost and to also improve the life structure of these houses. As the houses are built across the length and breadth of the island of Jamaica, with each land having its own unique topography, which sometimes results in difficult accessibility of the land. The current designs calls for a zinc roofing, wooden framing, and a 320 square foot plan area which is 3 inches thick and poured in place. And a typical strip footing which is designed 2 block height from existing ground with no ceiling in either the block pocket or concrete flooring. In a bid to suitably understand the desire to improve the current design, we conducted 2 site visits in rural Jamaica. At the first site, we saw that the house was located on a steep slope, which called for modification of the current design, as the foundation was now 6 block height from existing ground. We first investigated the superstructure, which was deemed acceptable as the connections were secure and there were adequate amount of hurricane straps along the trusses and the wall plates. We then analyzed the substructure, where we saw that there were deficiencies in the design, as there was movement of the foundation, cracks in the blocks, cracks in the concrete slab, and failure of the concrete slab. The team then conducted site visit to Site 2, where we saw similarities. However, the foundation was designed at a 4 block height from existing ground. We then focused our study on alternative forms of reinforcement for foundation design that are still economical for construction and are better when considering the life cycle. This was done by investigating bamboo and also wired mesh as reinforcement and comparing this to plain concrete. You may ask the question, how can bamboo be used as reinforcement? Well, bamboo is a versatile, strong, and rapidly renewable plant that has many applications in the use of construction. In 1966, the U.S. Naval Civil Engineering Laboratory provided a set of instructions on how to properly construct a variety of structures using bamboo. Currently in Jamaica, the Bureau of Standards are looking at constructing affordable houses using bamboo, which will be funded from the National Housing Trust with a $54 million contract. So we're hoping that our research can be of some value to them. You may also ask the question, how can wired mesh be used as a form of reinforcement? Well, it is a square steel mesh manufactured in flat sheets of high-yield strength wire. The advantages include that it weighs less than steel bar, it reduces cracks in concrete, and it provides proper distribution of stress in concrete slab. This form of reinforcement is also expected to control tensile forces developed in the concrete as a result of the natural shrinkage and also the contraction of the slab as it is being restricted from the frictional contact with the ground. The use of wired mesh can be seen in basements, ground sidewalks to control unsightly cracking, leakage, and deterioration as the building ages. In order to conduct the experiment, the methodology is as follows. The bamboo was firstly cut in splints, was allowed to cure for a week, and it was coated in environmental varnish to reduce the swelling of bamboo itself and to enhance the bonding between the bamboo and the concrete. It was also placed at a half-inch cover from the side of the beams and a 1-inch cover from the bottom of the beams, and it was secured using a binding wire. We then followed a similar procedure using an 18 by 4-inch wired mesh, which was also placed as a half-inch cover from the side of the beams and a 1-inch cover from the bottom of the beams. We then created formworks of dimensions 5 by 6 by 20 inches using a mixed design of 1 to 2 to 4, which was used to create 3 pure concrete beams, 3 bamboo reinforced beams, and 3 wired mesh reinforced beams. We also created 6 cylindrical specimens of dimensions 4 by 8 inches. When the specimens reached their desired strength, we conducted a 3-point bending test using a universal testing machine. This test provides values for the modulus of elasticity in bending, flexural stress, flexural strain, and also flexural stress strain in response to the material. The image on the left showcases the beam before the point of failure, while the image on the right showcases the beam after the point of failure. Results and findings. The 6 cylindrical specimens produced an average compressive strength of 3,238 psf. By using the failure loads obtained from the universal testing machine, we were then able to calculate the nominal moment capacity of the beam using the following equation, where P represents the point of failure load of the beam and L represents the distance between the two supports. We were also able to determine the compressive zone of the beam by using the following equation, where AB represents the cross-sectional area of the reinforcement and FB represents the yield strength of the reinforcement and FC represents the average compressive strength of our mixed design and B, which represents the width of the beam. We then conducted an iterative process using Solver in Excel, where we equated the nominal moment capacity of the following equation 3 to the nominal moment capacity of equation 1 to determine the computed yield strength, as can be seen in the table above. We then followed similar procedure with wired mesh as reinforcement to also compute its yield strength, as can be seen in the following table. Through our study, we found that the average computed yield strength of wired mesh was far greater than that of bamboo, as wired mesh produced an average computed yield strength of 10,776.5 psi when compared to that of bamboo of 725.5 psi. From our study, we found that the yield strength of bamboo was noticeably lesser than that of wired mesh, as previously stated. However, we believe that bamboo can be used as a sustainable form of reinforcement in concrete slab foundation for temporary structures, as it provided yield strength when compared to that of plain concrete. We also believe that further research is recommended for the proper functionality of bamboo as reinforcement. We recommend the use of wired mesh as the most suitable form of reinforcement for the current design, which is expected to improve the life cycle of the structures while maintaining a suitable cost. We then propose a slab-on-grade foundation design using a 125 wired mesh as reinforcement in the concrete slab, which was placed 6 inches center to center, and this foundation design was 2 block height from existing ground. This slide provides a list of some of our references, which includes Building with Sustainable Forest Products, Reinforced Concrete Construction, a comparative analysis of the tensile stress of bamboo and the reinforcement steel bars as a structural membrane construction, bamboo research in Asia, and also the ultimate behavior of bamboo reinforced lightweight concrete beams, just to name a few. I would like to say thanks for participating in this presentation. If you have any queries or feedback, I can be contacted at the email provided below. Thank you.
Thank you, Ms. Henry, for your presentation. Very interesting work on the bamboo reinforcement. I just appreciate your time, and it's a very good presentation. And then I believe that if there are some questions, I request all the participants and any questions to be forwarded to by email to Ms. Henry. I think I believe she's not in the chat room.